Hello everyone, my name is Mike Creasel. I'm the Director of Architectural Masonry here at Brampton Brick, and Brampton Brick is a title sponsor of this OAA conference, which of course is virtual this year. And our topic that we are going to be presenting is the enhanced curing of concrete block using carbon dioxide. So Brampton Brick, like I say, is pleased to be a title sponsor once again this year. So this is our learning unit that we're going to provide, and I will get going now. At the end of the presentation, I will be back live. So if you have questions, you can ask me in person or go ahead and send them to the chat bar up top, and I will read them and respond to them after the presentation. All right, here we go. So like I say, this is the enhanced curing of concrete block using carbon dioxide. It's an OAA accredited course, and because you're at the OAA conference, your attendance has already been marked. This course description. The session will familiarize you with the mechanisms governing concrete curing by carbonation, how this method presents a more sustainable alternative to incumbent curing practices, and will demonstrate carbon curing associated environmental, manufacturing, and product performance benefits. Three things we're going to talk about: the manufacturing process itself with concrete block, reviewing the Carboclave process, and understand the purpose and benefits of sequestering carbon dioxide in concrete products. Now, what I will say is Carboclave is a product that Brampton Brick makes, and we can get into the specifics on what products and where, but that's basically what we're talking about here. Let's talk climate change or climate crisis. Human activities have estimated to be have increased the temperature on the planet by about 1 degree since the industrial levels were measured in 1850 to 1900, projected to reach around 1.5 degrees by 2040 on average, again between 2030 2050. And the current rate is about 0.2 degrees per decade from the past current emissions that have been measured. The total annual amount that's been put out by humans is about 40 gigatons per year. You know, it seems small, but really not at all, because we're reaching about 2 degrees can bring about a catastrophic and irreversible change in terms of what happens globally. So let's talk the things that can come from that. Droughts, heat waves, desertification, glacier melting, sea rise. Of course, these are some of the big things that we hear. I don't often hear a lot about the coastal ecosystem effects, things like reefs when you get bleaching. Sometimes the increase in temperature and pH can completely devastate ecosystems under the water, which you don't see as often, so you don't think it's that big a deal. But again, the cascading effects. If the ocean becomes warmer and more acidic, then it can kill things like algae and fish. They have a huge impact on the human lifestyle. Algae does produce most of the world's oxygen, so if it dies off, then you can see there's going to be an issue there. Permafrost is another big thing that comes up because the methane is about 30 times more, has a 30 times higher global warming potential, I should say, than carbon dioxide. And there's lots of pockets of that around the earth that currently are frozen. One of which was in Siberia. It seems to be one of the largest ones on the planet. And if that area does thaw, then its potential for the methane to get out is obviously not good. So we're talking the climate crisis here. Again, whether you think it's a natural process or if you think this is just the earth taking care of itself or you think it's man-made, you know, there we go. What we can all kind of agree on is it seems to be happening faster and faster, especially when we're comparing with what we've measured in the few hundred years ago versus millions of years ago. You see obviously an increased rate. And again, we're looking at us as humans on the planet, what we've done since we've been here, and today's point in our life, of course, I can't think that we're probably helping the situation by pumping a ton of toxic chemicals and CO2 and other things into the atmosphere. So again, transit, manufacturing are probably one of the biggest culprits in that state. A quote from Bernie Sanders years back said, you know, no one wants to look your grandchild in the eye 30 years from now and have them say to you, you knew what the scientists were saying in 2019 and you didn't do anything about it. So let's talk about what we're actually doing about it. One thing is carbon pricing. We hear a lot about that in the news. It's a fee for polluting. So as an industry polluter, you're allowed to pollute as much as you want, essentially, as long as you pay for it. So the idea being that if you pollute an awful lot, you're paying an awful lot. That comes off your bottom line. So to correct that as a company, if you'd like to stop paying that, then you need to stop polluting. So the program seems to make sense. There's certain incentives that you get out for low carbon technologies, sequestering carbon dioxide. You do get incentives for that. And again, it's a sheer knock on the budget if you just keep ignoring that. Obviously, it's probably more financially responsible to come up with something that is a bit more carbon friendly, and therefore you can then stop paying for it. But some of the drawbacks is that some of the companies, or countries I should say, can actually swap and trade some of these things. So that may not help in certain areas, but for the most part, I think a lot of the nations did adopt this in the Paris Accord, but more needs to be done. I mean, probably some of the biggest emitters may not be actually part of this whole thing. And we need a global commitment, because this isn't something that's just specific to companies. This is specific to humanity. So some climate targets, if we look at some of the information that's been put out there, 30% of the reduction by 2030 and 80% reduction in CO2 by 2050. And that's from 2005 levels. If you're looking at the deeper targets, you're 80% by 2050 from the 1990 levels. So you can kind of see here in the chart where we're trending, where we need to be, where we want to be long term. So it's obviously going downwards. Again, looking at some of these mitigation strategies, you're trying to phase out the big emitters like coal. Carbon pricing is helping to reduce some of those bigger polluters, reducing the methane gas from the oil and gas refinery. A lot of those things you see in the smokestacks just burning off, and coming up with alternative low carbon fuels, things that you can supplement, like in cement, you're using slags that have a lower carbon footprint. So you're trying to get to negative emissions is the main goal. And you can see here where the UK and Canada, their targets and our targets, so they're obviously doing a little bit better job right now. Canada's not quite going down the way it should, but we have to kind of get there. So we talk about carbon capture and storage, how it's currently done now. There's essentially three main ways that you see, and you probably don't see much of it in the news or media. But there's a geologic type of sequestration, so essentially taking carbon dioxide and pumping it into the ground. So in this case, it may be where there's pockets in the ground below, specifically where you're mining oil and gas. So when you remove all that liquid, you may be able to pump the gas back into that chamber. Now, when you're putting CO2 back in the ground, calcium carbonate, it actually kind of forms like a crystal. And I'll get into that a little later on. But what you're doing is you're pumping in a gas into a pocket, a lot of sediment, a lot of gravel, a lot of stone, and it kind of fossilizes or hardens up and turns into a mineral again. Oceanic, same idea, large pockets or spots where you can actually dump them in. There's actually a few locations that are on grounds too, like abandoned mines. Sometimes you see, has a lot of space. They pump a lot of CO2 in there, but they're like a glass. You can only fill it so much. At some point, it's full and they cannot take anymore. So, it's a good method it's a short fix, but it's not a forever solution. And then there's mineral sequestration. So using carbon dioxide to help make other products like carbon fiber or nanoparticles. I mean, there's things that people are coming up with every day that help use CO2. Problem is that we produce so much CO2, we're finding it harder to use just as much as we produce. So right now there's kind of an imbalance. So we're trying to find out ways to obviously make that, close that gap. One of which is concrete. So like I say, calcium carbonate is essentially limestone. You can obviously tell there's a lot of limestone in concrete, so it's a natural fit. Concrete being one of the most widely used commodities on the planet other than water. You have wet mix, ready mix, segmental units like you see at the bottom. So there's different types of concrete you see out there. Global annual production is around a ton per capita, which is obviously quite a lot. Concrete itself composes from aggregates, cement, and water, typically. There's other smaller ingredients, but primarily those are your pretty common ingredients with concrete. It has a high affinity for CO2. Cement bonds very easily and quickly to carbon dioxide. Now, if we look at the hydration process, this is obviously the chemistry side of things. When you take cement, you add water, you get cement paste or concrete, essentially. But what we're looking for here are two elements. There's a CSH, which is a calcium silicate hydrate, and that's probably the most important part of the reaction because Easiest way to think of that is the glue. So that's actually what bonds your aggregates together, and a CH, so the calcium hydroxide. This is a byproduct of the reaction. That's generally not one that we want. So sometimes you hear of alkalinity in cements, alkalinity in concretes. Again, not a great thing, because it does help lead to things like damage in concrete. So efflorescence, sulfated tech, corrosion. So CH is kind of the thing we want to try and mitigate as much as possible. So if you're looking at it on a small scale, when you're using CO2 curing, so again, we're talking about a chamber full of concrete block, and you're pumping in carbon dioxide as the reactive element instead of adding a lot of heat and hydration, which you typically do with concrete. When you stick it in a hot, wet chamber, you let it cure. If you use CO2, it generates CSH, that glue, at a much faster rate than normal hydration, and that's what we call normal hydration of curing of concrete. Also, instead of the CH, reaction forms a much more suitable and soluble calcium carbonate, so like a crystal essentially, which is kind of what you see here in between. So this is the before and this is the after, where you have these calcium carbonate crystals that are trapped in the CSH. So you're not really getting the negative effect of the reaction. So you're getting rid of that CH if you do use CO2 as a curing mechanism. If you look at the typical graphs and typical strength charts here, you see with CO2, you do get an incredibly high strength right out of the gate. So this is a 1-day cure. You see the days here, 1 day, 28 day. And in 28 days with heat hydration versus carbon curing, you're actually seeing that it's actually marginally higher in the first day than 28 days of typical curing. So that's obviously a big benefit. And when you talk about manufacturing from our standpoint, moving it around, handling it, treating the units, all that kind of stuff, that is better if the units are stronger. So typically we'll wait a week plus before we do things to concrete. This may allow us to expedite some of these processes that we do, or move it to site even quicker. Now, Carboclave technology itself isn't just for concrete blocks. It's being adopted into larger slabs, bridge decks, concrete pipes, not to mention what we do is typically your segmental units, these individual pieces here. So it's kind of a different technology that we're looking to use in all different facets. The Carboclave process itself, so you're starting with a typical industry. So you might get like an off gas from, honestly, it could be anybody. Like our carbon dioxide actually comes from a food processing facility, because you want to make sure it's as close to your point of manufacturing as possible. So it doesn't have to be a cement factory. It doesn't have to be industry. It could just be anywhere that's kind of close that is a large CO2 emitter. Now, companies like Prax Air Liquide, you probably have seen their trucks floating around. They're the companies that we hire to go out. They actually take all the gases from manufacturing. They'll refine it. They'll take out certain particles like nitrogen, oxygen, carbon dioxide, and they'll sell those components back to manufacturers. So we actually just purchased the CO2 from them. So as you can see, CO2, they come in, they fill up our tanks, and then we will actually set them into, if you're doing precast pipes or anything like that, like a beehives or a scenario kiln, you can pump CO2 into there. Or what we do is a low pressure. Now, you've probably heard of the term autoclave. At our Cambridge plant, we have one of the only, there's 2 companies that still have autoclave systems, and we have one of them. And currently, we actually use a low pressure system with the carbon dioxide. So it's like a submarine with you lop the ends off and bolt the doors on. So the product goes in there. It sits in there for 12, 14, 16 hours. Really depends on what's in the amount of concrete. And we pump CO2 in a low pressure. And that'll gives the concrete time to uptake the CO2. And because it's low pressure, it drives it into the concrete. And at the end of the cycle, you open the door and there's virtually zero CO2 that actually emits from that chamber. So you know it's been uptaken. So that can be what we use for your concrete masonry. It could be bricks, blocks, stone. Again, you're thinking of our company, Brampton Brick. We have a lot of concrete masonry, but we have just as much on the hardscape side. So this is something that we could possibly look at adapting for the concrete landscape side, retaining walls, paving stones, that kind of thing. So let's look at some of the benefits you can get with Carboclave. So of course, you get the high early strengths. You avoid steam. So if you're doing a typical autoclave, or if you're doing a bubble cure type system, you have to heat water really hot to create steam. So you're losing a lot of energy to do that. So if you're avoiding the steam, you're saving about a liter of water per 20 centimeter block. So it does add up to be quite a lot. I'll show you a video in a second of the water that does come out of the kiln. You can reduce your cement. Now this is one that all producers, we kind of look at this and we're a little bit hesitant because we know that the science is there. It's just because concrete block is a load-bearing product, we want to make sure that we are at the very least going to produce the strength you need for your walls, because what we don't want to do is produce something that's going to underperform. So right now, we know that we're getting more strength that we need. Down the road, we can start looking at reducing the amount of cement or types of cements that we're actually using in our concrete products. It does divert CO2 from the atmosphere. Like I said earlier, we can take CO2 from closest local emitter, we'll refine it. Companies refine it down for us, they sell it back to us, and we can direct sequester about a quarter of a kg of CO2 into each 20 centimeter block. It can turn your plant into a net negative CO2 or have a net negative footprint on your operation, because it does reduce the carbon footprint and the costs. 28D strength in 24 hours is obviously a huge thing, and it improves the concrete resiliency, the durability, and the service life performance, because as you'll see in a minute, it does help reduce those side effects because the CH is no longer there. It helps with the shrinkage of concrete, absorption, efflorescence potential, water absorption, sulfate attack, and things like freeze thaw that always tend to hurt concrete through its lifetime. So these are some of the, if you look at a premium product, and we call premium products things that use high-end aggregates, typically if you're doing a ground-faced or a shot blast. So you can see over here, this is like the ground-faced concrete unit where it looks almost like a granite countertop, for lack of a better term. So we're looking to get high early strengths. It can definitely help because we can treat these things sooner. You have less chippage or breakage. If it's not as strong when you treat it, sometimes you flake off the edges. So being nice and strong, it does help with the grinding and polishing. And then here you'll see on the right-hand side versus the left-hand side, here's a steam-cured block versus a carboclave block. Again, carboclave does not use a lot of heat and humidity. Steam curing obviously does. And sometimes you get this sort of, I'll call like a milky-like substance that you see on the side of the unit. So, or like a hazing. You can get that on the sides. Typically concrete block, though, you're going to do one of these treatments to it, so you don't generally see an issue with it. But obviously, if we can avoid some staining on the units during the manufacturing, that's ideal. Talking about the product performances themselves, again, you can see your typical autoclave system versus a carboclave system. It doesn't seem to change too much of your densities and absorptions, although again, you can see it does increase density by a little bit because it does make sense. The gas goes in as a gas and turns into a mineral or a solid. So it is taking up space. So by taking up space, it does increase the density marginally, and it does reduce the absorption because it does sort of reduce the amount of pores that are in there. But overall, again, what you're looking for here is your strengths. So your 1 day versus 28-day strength. And again, you see it's a big increase in strength right off the hop. And this is where our target is. So a 15 MPa block. Most manufacturers will never make a block just a 15 MPa. You want to make sure you have a little bit of a buffer zone there. So you're typically around 20 MPa for the most part for concrete blocks. You want them certainly to be stronger than they need to be. So again, there's some other product performances. You reduce some cement. You're sequestering carbon dioxide in there. But some people ask, how do you actually know? So I'm going to probably murder this pronunciation, but phenolphthalein is a pH indicator. And what you can actually do is you can you squeeze that or soak your block with it. And what you'll actually do is you'll see anything that turns pink is in concrete is going to be higher on the alkali side. Anything that's less than that is going to be just a typical brown or a concrete color. So the point of what that is it's showing you that you're kind of getting like an outer layer of protection around that concrete unit, which is what we call a carbonation modified surface. So that's where the CO2 actually sequesters into the concrete units themselves and kind of embeds in. So that's during the curing process. That's how we know it actually does uptake. But by doing that, you're almost kind of giving it that layer of protection. So makes things harder to get in, also makes things harder to get out, which is what helps with efflorescence, because efflorescence is always there whether you like it or not. It's a salt-based product, but if you can prevent it from getting out, then you don't see the efflorescence. Things we can do with the freeze-thaw cycles. Again, you're looking at a carbonated product versus a steam-cured product. After 20 cycles, you can see the difference between the two. So these are very aggressive cycles, which are using de-icing salts. We want it to fail. That's the ASTM C666 test. So you do see that they are failing, but they are failing differently. There's also day 1 versus day 25 of the C67, the modified one, which meaning you don't just leave it in a pan, you leave it with a fan on top, because that is more indicative of real life, where you have the unit in situ and you have wind blowing over the top. So that's going to help draw and pull the moisture out of that and make sure that it gives it like a worst case scenario, which is what we want. We want that in the lab scenario, because we know if it passes that, it'll pass the everyday rigmarole. If you're looking at efflorescence, again, if they're carbonated versus steam cured, so steam cured, you're getting a little bit of that efflorescence hazing on the surface. Carbonation, you're not. But again, you're seeing this little level here where you see that little white line. That's that modified carbonated surface, and that's kind of preventing and holding this efflow from getting out. It's stopping the migration of that out. Whereas on the steam cured, you kind of see it rises to the top, and that's what we see in the top of the units here. If you're looking at sulfate attacks, typically what we see in the ground where people retail plazas, that kind of stuff, they put a lot of de-icing salts and things like that down, and the gardener, those types of applications with concrete. So if you were to use something with a CO2 sequestered, these are just cement cubes that were subjected to sulfate attacks. And after 6 months of testing, which is quite a long test, you'll see that the steam cured cube looks to be a little bit rougher. It's actually, if you look at it or if you're able to feel it, it's a lot like gum or jelly. So it does wiggle around. And the carbonated versions are still quite hard. You do get a little bit of that scumming on the side, but it's the consistency is still concrete. It didn't change from basically a hard solid to piece of chewing gum. So that's one of the biggest differences there with the durability side of it. So carbon sequestering verification. So they say, so how do you actually know what goes into it? Well, there's only really one way to know. You can weigh the units themselves. You can actually cut into them and look at under a microscope and look for these little calcium carbonate crystals. I kind of say it looks like moss growing between aggregate, so you can always tell if it's been carbonated or not, if it has like this little moss that grows between the particles. There's also another one is thermal decomposition. So essentially, you're taking units itself, you weigh them out, like you see here in these cups, and then you have to basically burn them, which is how you make cement. You actually have to break that calcium carbonate, so that CaCO3. What you do is you release the CO2 gas, and you're left with calcium oxide. So you're left with CaO, and the CO2 goes in the atmosphere, or in this case, it is captured. Or in this particular case, we'll just measure the weight difference, and that difference is going to be the CO2 that left the sample. So that's an easy way to measure how much carbon dioxide actually was in that product. So if we're looking at typical ways of the curing process, so again, you've got your steam curing, you have your aggregates, your cements, your water, and then you add that steam effect, heat hydration. If you do it the carbon cure version where you're just using carbon dioxide, in theory, you can reduce about 25% of your cement. Obviously, we're playing with different levels of that as well. You can use other supplementary cementitious materials like slags or blast furnace slags, fly ash, depending on where you are. And initially what we're getting with using the CO2 is about a 50% reduction as a carbon footprint of making concrete. Now, again, we all know cement has a high footprint, but that's cement, and we use a portion, 10 to 20% of our batch with cement. So carbon, making concrete itself does not have a huge carbon footprint, but the cement part of that does. So it's important to keep a note of that. When you make concrete, you basically just use pneumatics to push it together. We're not actually burning any fossil fuels. When it comes to LEED credits, of course, there's some innovation and technologies that do come into play. We're talking recycled content if you're using carbon dioxide. So I always say, make sure you reach out to us if you have any questions, and we can review each project on a specific basis, because there's a regionality portion, of course, but then we're also looking to see the volume of concrete you're going to be using, where you're going to be using it, so on and so forth. So if you look specifically at our plant in Cambridge, known as the Beamers plant, right now, if you were to measure up to 2020, almost about 10 million blocks have been sold with the Carboclave technology as of last year. We do about 20,000 blocks per day is the capacity. Of course, that can change if we're doing switches or changing products itself. On average, we're sequestering around 5 tons of CO2 per day, depending on how much the units that we're actually producing. And 1 million kgs of CO2 sequestered each year is our target. So again, not everything we make is going to have that in there. Some of them, most of what we do already has it in, but sometimes we make it without that, depending on the project. To give you an idea of some projects that we've done in the past. So again, you're looking at this large hotel, and you'll see this in the video too. It's just kind of a nice screenshot, though. This is something that you can help promote or sell to your customers as well, saying, you know what, this project is going to sequester so many pounds of CO2, and it's a pretty easy calculation. As long as we know roughly how many square feet of block we have, we know how much CO2 is in each block, so we get a ballpark figure. And again, we make it with it integrally in our block anyways. So if it's something you want to promote, great. If you don't, it's in there anyways. So even after the fact, if you are going to go for LEED certification down the road, or if it's something you want to promote, like I say, it's if you're using our block, it's in there whether you like it or not. So why not? You know, this police facility here, 17,500, 22,500 pounds, 30,000 pounds of CO2 in that apartment building there. So again, it's just a good thing to see. Helps with the marketing side as well. So as I mentioned earlier, when you're producing it with the carbon dioxide, in theory, you can use less moisture because you don't need to create heat and humidity. But also, when you're putting in the carbon dioxide into the concrete, it actually squeezes out and gets rid of some of that moisture. So I'll show you a quick video here. This is what it looks like at the end of the curing cycle. You'll see the moisture actually come. So it's almost like a natural spring amount of water, it just keeps flowing out. And that's the door to an autoclave chamber. And then here you see the different rows of blocks, different racks of blocks, and that whole rack will slide out. This water will keep coming out for a good 5-10 minutes afterwards. Keeps its way all the way to the front. So of course, when we're talking LEED, it's not always about what you're manufacturing, it's kind of what you're using to manufacture and where it comes from. So there is the negative side when you're accounting for how much CO2 is actually sequestered in your project. So we are 0.05 tons of CO2 emitted per ton of CO2 captured and delivered. So what that means is that we actually incur a penalty, of course, because there's the processing and the liquefaction of the CO2 from when they capture it from another industry or another emitter. And then there's distribution, so it has to get from them to us. So if we're doing, that's why I say every project kind of has to be unique, because we have to make sure we know where you are, where we are, and where the product comes from. So when you're doing EPDs and that sort of stuff, it always has to be project specific. But this is the sort of the reduction in amount of CO2 that we're able to sequester for every block or for every project. And that is always taken into account for all of those projects. Here is the other video I'll show you. And I do this because it shows the manufacturing process, and it's just a better way to see it. So the music is pretty catchy. Try not to stand up and dance while that's happening. So you'll see some of the slides we've talked about already. But it's primarily to show you the plant process and how it all works. So some of the things we already spoke about, just presentation so far. So carbon dioxide turning into calcium carbonate crystals. Some of the different areas of the company, not necessarily us, because Carboclave can go elsewhere, other technologies or other manufacturing facilities. There's our beamer's location. You can see the chambers off to the right-hand side there. This is a heat of hydration, so those are chambers that are just steam, we're steam cured, they're not pressurized. These are the pressurized versions, so you can see they look like gigantic tubes off to the side of the product goes in, closes, and cycles through the amount of CO2 at certain intervals. There's a low pressure version where it's small chambers that have a door that closes off, similar to autoclave, not exactly the same. Again, so the benefits that this video, actually, if you're curious to see, again, it's on our website under the little section here. Carboclave. Check some of the projects that we looked at there. It's always tricky, especially when they're in behind the wall. You always have to make sure you get out there in decent time before they block it in. No pun intended. Okay, so there's the video. So that kind of ends the technical portion of the presentation. I'll just conclude here with a few extra slides on Brampton Brick. So, like I said earlier, if you want to see this stuff on our website, we did just redo our website early this year in 2021, and you will notice that the website now has both the masonry and the hardscape. So, as I mentioned, hardscapes being the concrete pavers side of things. So, if you're into the products tab at the top, you can find your way to the concrete block section, which will then show you all the Carboclave products and the Carboclave technology itself. So again, if you're into products, you can say clay, concrete, stone, or accessories. The new website's divided into almost like a filter on the left-hand side. You can sort to see what you want to see. So these are all the clay brick products. There's your concrete block, there's split-faced, there's your Carboclave product, which actually is in all of these other products, but it's got its own little tab. And then we have the concrete stone side of things. So those are the three main masonry topics. On the resources tab, of course, feel free to reach out to me anytime. I think hopefully I've met most of you that haven't. Hopefully we'll see each other soon. But you can always reach out to the website, bramptonbrick.com, and go to the resources tab. And anything that you need to look for, I would say start with the resources section and go to the search. You can type in whatever you want. It's a pretty intuitive search. Looking for master format spec, you type in master format, it'll show what you're actually looking for, and it'll take you to a section, in this case, where you can download the specifications from our website. We also have Revit files available for the clay and concrete products that we manufacture. You can also find brochures, the residential or the commercial brochure, same products, they just show it differently. And then technical data sheets are something that we get asked for quite a bit these days. So product data sheets and technical data sheets. The technical data sheets actually are more encompassing. It's like a specification, you know, how it's manufactured, sizes, colors, finishes, how you install it, how you clean it. In this particular case with concrete block, this is the chart that shows you the ratings for concrete block for different fire ratings, different hours, different weights, different sound characteristics and properties of concrete block. So if you need that information, feel free to reach out to me, but if you can't get a hold of us or you want to look for it yourself, be sure to find that on our website. A couple of things that are new for Brampton Brick. Now, these particular things are not Carboclave, but they can be accompanied with the Carboclave product. Aster Glaze is a new product that we have brought on, and this is the glazed concrete block product. So you'll see here basically any color you want. It's a bondable surface. It's a resin that goes on the concrete block. So we do have that now available. And Sound Block is a product that we now have because another manufacturer actually left the business. So we have picked up the slack. So Sound Block is something that we do make with Carboclave. So these are typically units that are either architectural, meaning colored units or ground-faced units, or just simply a standard finish. But they are all manufactured with Carboclave. There's a separate page on our website where you can find the chart you can download and or just look to see what size or type of block you need for your application. Of course, I do have the lunch and learns on the masonry side, and I have my colleague Glenn Harold does all the landscape topics. So if you want some other either OAA or AIA structured hours, there are available on the OAA website, the Oaks and the Brampton Brick. We also have just product presentations if you're curious and just getting up to speed with what is new for this season. So with that, I'd like to thank you for your time, and hopefully that was somewhat entertaining and you learned a little bit about the Carboclave process. Like I say, I'll be around, hopefully listening to myself at this point, and if you have any questions, please feel free to go ahead and ask. So I will sign off for now, and again, thank you for attending, and good luck with the rest of your OAA conference. Take care.
You guys enjoyed the presentation. Better if I was in person, a bit more lively in person, but appreciate you taking the time to listen to the presentation. So I do have some questions here. I was looking at a couple of them, and some of them may be something better to be discussed at the booth or even maybe a bit offline as well, because I'm not exactly sure the detail you want me to get into. But I will start with Lowell. It said, asked a question about India supplying most of the cement for the world by burning coal, and I don't actually know the answer to that question, so that may be one that we should possibly discuss after the fact. I mean, this technology itself can be implemented anywhere in the world. You just need to have the basic components for making cement, and then the technology itself, which is a licensed product, and then a facility where you can make the product. So that question I may have to get back to you on, or maybe we can discuss at the virtual booth if you don't mind. John Holland had a question too. The production of cement emits CO2, correct? What is the balance? Now, the production of cement does emit CO2. So there's kind of two ways that CO2 is emitted from creation of cement. So when you burn a fossil fuel to create that temperature, you actually do split that calcium carbonate atom. So the CaO goes off this way and the CO2 goes this way. So that goes into the environment. The other, of course, is burning the fuel to create that. So you kind of get double dinged on the cement side, which is why they're really looking at, as a cement industry, why they're looking at coming up with different ways and different methods to create cement powder itself. Now, again, creating concrete block or other concrete products uses a fraction of that cement in our mix, which we will also try and use supplementary cementitious materials to try and negate the use of cement. So they're seeing a lot more of those things come into play. One thing I will mention though is that in some products, you can only use so much of a supplementary product before it actually has adverse effects on the product itself. So in other words, if you have cement and slag and you add too much slag, you can actually create a problem for the cement itself, like the concrete that you're creating, it will be very weak. So it's almost like a bit of a bell curve. You can add enough of something to get to a point, it plateaus, and then it actually starts coming back the other direction, which you obviously don't want. So I hope, John, that answers your question. If not, like I say, come grab me at the virtual booth there. Alexander mentioned sequestering is 95% efficient based on processing and transportation. When you factor in the lifetime carbon footprint of a carbon block, what is the net carbon footprint of your blocks? Now, that is another question, a very good question, and that is speaking to a larger picture for the concrete or the cemental block in space, because what we're trying to do is say that concrete blocks, yes, although they do have a footprint in manufacturing, the longevity of them or durability of them should come into play. So typically what we do, or when we do our calculations, we do have to have specific projects to say from where we are to where it's going. There's the reduction to get it from plant to site, but you're right, it's the overall life cycle assessment that does come in. I don't actually know that number specifically for one block, but that will be something I can maybe take back to the team and ask them, because that's a good question. And I think that might help sell it. You guys can then sell it to your customers, the owners that you'll be dealing with. So that might be something to keep in mind. So Alexander, again, it might be something that we should maybe chat about as well later. Paul, in general, where does the cost of the CO2 cured CMU compare to conventional cured CMUs? Now, I'll maybe spin that question a little bit. So the cost of CO2 curing is a little bit higher than the cost of just regular heat hydration. So in other words, we're just heating water up so that it evaporates into the chamber and creates that moisture for the block to cure in. Adding CO2, of course, we have to purchase the CO2. Now, depending on how much you put in and your process you have, it is a little more expensive to cure with CO2 because, again, it's something we have to purchase. But in general, it doesn't affect the actual cost of blocks. So Brampton Brick, what we're doing is that we're actually trying to just put this into our process, whether you like it or not. Again, it does help with the manufacturing standpoint, some of the points I did mention. But we also notice that it's something that it's just generally good to do. So we're just going to continue to do that. And by doing it that way, we're hoping that we get more business because of that. And we do see that already. This year is a weird year again. There's already starting to be shortages on concrete block. Not saying it's this specific reason, but it's just a nice added benefit because typically projects that we find that want to use a product like this are things like schools, institutional work, where they don't always have the budget for it, but they want to be green friendly, or they want to have something that's sort of environmentally responsible. So by having it just as the same price, it really helps the larger users, which typically, again, are those institutional projects. They don't have to decide between a regular block or a Carboclave or a carbon sequestered unit. They just get it, again, like whether they want it or not. So that's kind of how we're spinning this, and that's how we've been doing it for the last few years. We also had one called Carbon Cure way back when, which is the first iteration of a carbon sequester product. So we've been doing this for the last, I think 6 or 7 years now. So it's the way we're going, and especially the way the industry seems to be going as well. Marcelo, let's see, why are the projects highlighted a total contradiction within sustainability? 50-foot lot wide detached dwelling. Not really sure. Not really sure what you're asking there. Maybe come chat with me at the booth afterwards. We highlight the projects because we're showing how much carbon dioxide is actually sequestered in the units. And that doesn't mean what the footprint of the building construction is, if that is what you're looking at. But I'm not, again, sure if that answers your question. Colleen asks, are all of your products using CO2? Now, right now, everything manufactured at our Cambridge location is. There is a plan to extend that to potentially other facilities. So everything we make in our Cambridge plant would be lightweight, standard block. We are making some architectural units there. So again, our profile series or our standard and lightweight blocks have it in it already. We are looking to, like I said, access that to other facilities which do make other, like finesse or the other concrete stone, as well as the hardscapes. So that's something that we're looking at to get into the landscape paver world where you're talking retaining walls and paving stones. So yes, there are some that are base that have it in it already. And on the website, if you look at the product data sheets, they tell you if it's in or not. And again, if not, you can certainly specify it for certain products, but that might be something that you would want to reach out to a Brampton Brick rep for. That kind of answers the next one, which ones you make Carboclave technology with. Generally speaking, it's just concrete block at this point. And then are there any additional costs for Carboclave? Kind of mentioned that already, so that there isn't any, so you don't actually see an increase in cost. Our price list stays the same. It's just knowing that it's already in there. Another question here, if Carboclave technology needs carbon, does it mean you are using carbon which is emitted? Good question. So the answer to that is no. So what we can do is we take, in the video you saw the big white cylinder that was outside of the plant. So that's where those third-party companies come in and give us the CO2. So when we put it in that big, massive, I call it like a submarine with the ends cut off. When you put the block in there and you pump the CO2 in there, you can actually meter the pressure as it goes. And what we can do is we have a little gauge on the outside which tells you how much CO2 is left in the atmosphere inside that chamber. So we know if we put in 100%, you go down to 1 or 2%, or even not even readable at some points. So we know that the concrete block actually does absorb that CO2, because again, it's doing it naturally with that mineral sequestration. So we do know that when we open the door, CO2 doesn't just leave the chamber. There's actually virtually nothing left in that chamber that hasn't already been absorbed by the concrete block. Just to be clear, you are using CO2 and extracting CO2 in the process. No, we are just using CO2. So we purchase the carbon dioxide gas and we pump it into our concrete block, and it absorbs into the block. So we do not, we don't do the extraction ourselves. It's a third-party company, and we don't create any CO2 by the manufacturing, because I mentioned in the video that we just do pneumatics. So everything we do to make concrete is just pushing it together. So we don't actually burn fossil fuels to make a concrete block. Okay, they're coming in hot and heavy here. Hold on here. Discuss cost comparison from William. So I think I kind of mentioned it, but in general, our cost comparison. So if we were charging $3 for a block to the market before Carboclave, we're still charging $3 to market with the Carboclave product in it. So again, what we're doing is we're sort of offsetting our costs a little bit, because we do have a bit of water reduction savings versus that curing method. And also we just want to make sure that we do keep it the same, because we found in our first rounds where we did have an increase in price. As you know, a lot of builders and owners, they're going to say, I don't want to pay the extra price for something that's just a concrete block, because half the time you don't even see it. So we found that if we just brought it down to the same price point, that we were actually starting to sell it and take that choice away from the consumer. That way you're not having to choose, do I want to go this way or that way? We're just saying, this is what you get if you use our product. And I think it's been a good way to go, and we've been having success doing it that way. One last question. Do you consider developing pre-finished concrete wall panels for commercial projects? So the biggest panel, I guess you would say, is we do get into a 1 foot by 2 foot size. So that wouldn't be necessarily what I would call a panel. If you're probably talking something like a precast panel that's hung from a building, that is a whole different environment. That's a wet mix. What we do is a dry mix facility where you basically have zero slumps. You press it, it stays its shape. When you get into prefab concrete walls like that, I assume you're talking about something that's wet cast, so it has to be poured in place, cured, finished. That may be something where they want to go. I think in general, the industry probably will push a technology like this along. So you may see something happen there, but it is a different setup, because the curing is where the action happens. So it might be trickier to enclose that entire spot to then let the concrete absorb the CO2. I have seen other ones where you have CO2 sequestered aggregates. So you're starting with products that already have CO2 sequestered, so you don't have to worry about the curing side of it. But when you're letting the concrete as it cures, or using CO2 as a curing agent, then you do have to have a space for that concrete, and a time, could be 12 to 24 hours, for that concrete to absorb all of the CO2. So at this point, the biggest panel, I guess I would say we make, is a large concrete block that's a 1 foot by, I should say a stone, it's a 1 foot by 2 foot. Biggest block would be an 8 by 16. And there's been a number of projects that we've done that I could show you examples of how it looks. From Priscilla, has COVID-19 impact on production of masonry and cost materials? Good question. I don't know yet. So in general, I would say COVID has increased the sales on our hardscape side. So we're seeing a lot of that, like people doing their backyards and everything. On the masonry side, we have seen, on the commercial side, kind of a bit of a blip in terms of the demand. So I don't think it's gone too crazy just yet, because commercial jobs probably have a longer life cycle than what COVID is, at least to date. Residentially, we're seeing a lot more residential houses go up. Of course, there's a lot of block between them, so we have seen a bit of a spike in that end. But in concrete, I would say, whether you're ready mix or precast, we are seeing some issues with cement. So in terms of the supply. Also, I have been hearing things with pigments. So anything that uses a pigment to create the finished color has had some issues. Even clay brick, there's been some pigment supply issues. So we haven't seen things that we haven't been able to deal with, at least from our perspective, just yet. But I do know that there are things that I have heard rumors in the last month or so where, and we haven't even really gotten into the huge busy season yet, where it's potential that we might have some issues with some demand. But right now, we've been able to keep up to the demand so far. So I'll put it that way. But down the road, I do see probably more so with our raw materials causing an impact more than what we can produce. Do you foresee a future with building materials, cladding, performing carbon sequestering after installation? Now, that is a good question as well. And I should maybe chat with you after this, because I don't know how much time I have left actually. So, but there is a study going on that we're literally just starting this month, and it's through the NCMA. And we're looking at how much carbon dioxide do the building materials take on naturally. So that we won't know an answer for another 2 years. So I'll put it that way, but it is something that we are looking at. And that has been something that we are sort of aware of. So when you're sequestering CO2 at the manufacturing level, it's a different type of, you're not sure you're sequestering CO2, but it's also doing something different to the product versus a regular concrete product just in the environment soaking up CO2. So we do suspect that it may be like a sponge where it does absorb potentially similar ranges of CO2, but we're also hypothesizing that because you're curing with CO2 to start, you're getting a better cure, you're getting a better block, and you will potentially sequester more CO2 by doing it that way than just sticking a block in the environment and letting it take in CO2 as it lives. So it's a great question, and we've had that discussion at the industry level. So talk to me in 2 years and we'll have an answer for you. But right now, it is something that the industry has started to look at. From David, has the color fastness of SpectraGlaze block improved? So I don't know the answer to that, but maybe we could have a discussion at the booth as well, because we are fairly new to the SpectraGlaze product. Now we are in Astroglaze, so SpectraGlaze, I believe, is another supplier, but it's the same sort of thing. So you're basically putting like a resin or a glaze on a block to come up with literally any color you want. So there are color palettes. If not, you can choose custom colors, or even in the one image you saw, you can put an actual logo or an image on a block. Now, whichever product you use, it's not cheap, it's a very expensive unit, but it does give you a very unique look. But I would have to say for the colors, I don't have that much experience in the longevity of it, because again, we are new to the product, but I haven't been made aware of anything like that where it's been an issue over the long term. But definitely we could have a chat and figure out maybe if you have specific examples so that I can get back to you on that. Colleen, do your synthetic stones use Carboclave? Our Finesse series does not yet, because that's made at the a different facility. So right now we're literally just talking about concrete block products. So it could be a profile block product, which looks like a stone when it's in the wall proportion wise, or just the standard lightweight units, which probably generally go behind the wall, so they're not really aesthetic. But down the road, we would like to also consider doing something like that, where we are introducing that into the rest of the concrete umbrella that we do have here at Brampton. From Mark, does the traditional process block continue to absorb CO2 over the life of the project? Yeah, so that is kind of what Hamid was asking a few minutes ago. So yes, we know it does, to answer your question. How much, we don't know yet. So that is what we are going to be testing. So we're hoping to find out in a 2-year span that it does get to a point, and we're hoping that as we measure the CO2, it will actually start to tail off. And you may ask the question, how do you do that? Well, we actually have to send 30 different blocks manufactured from the same time, because you do have to, in the one image there I showed you, you have to break it and burn it to figure out how much is in there. So it's a destructive test. So what we have to do is take each of these units all made at the same time, and they're left in the environment. And we're hoping that after a period of time, we see a plateau with the amount of CO2 that's sequestered in those blocks. So in a couple of years' time, we will know how much exactly, but we do know from just general testing that yes, concrete and concrete block does naturally absorb CO2 from the environment, because again, that's what it does chemically with carbon dioxide. It leaches on to the concrete itself. but you want it to absorb in all the way to the concrete, so it's not just a perimeter sequestering. So yes, we will get back to you guys, and certainly I'll give you guys an update after that. So I've been told that's my last question. Thank you very much for all the questions. I hope you enjoyed the presentation. Sorry for the monotone voice. Can't do much about that. I was just staring at a wall for 45 minutes. So hopefully, if you guys have any questions, just like I say, come find me in the virtual booth. I'll be there for a little while still. And if not, you can reach out to me at mcreasel@bramptonbrick.com, or give me a shout on my phone. All my contact is at the booth as well. Feel free to call me or email me if you have any questions. So with that, I think if the OA folks, if you're happy with that, I'm good. Again, thanks for the questions. Really happy you could join. Glad that we're part of the conference. And like I said before, hopefully we'll see you next year. If not between now and then, hopefully we'll see you in your driveway when I'm giving you samples. Okay, take care, guys.